So we're recording okay? Wonderful. Thank you so much, Ivan. Today, it's our great pleasure to have a guest speaker with us who has been an academic over the years in the battlegrounds of academia, working with software and how to get it integrated into our curriculum to enable our students to be job ready by the time they graduate to work with industry straight in the workplace. And that job readiness, we've had some really good conversations with John over the last little while around the reality of students needing to be agile in learning how to learn new software. So we've been on some deep dive experiences inside our School of Engineering and Built Environment at Griffith University with a couple of MOU partners with Bentley Software Systems and Siemens Software. And actually John's history is in and around the Siemens software. And first and foremost, I think, John, for you, it's as an academic, using that software to deep dive in enabling some pretty cool creative experiences and outputs from students. So John, you're from Utah University until a couple of years ago, and then you've been winding your way around the world. I'm sure you'll share with us your insights around that, extending beyond engineering into art, technology, and a bunch of other places, so that we can learn a bit about how you've experienced that digital agility challenge as you've gone through your software teaching journey. So hopefully that's enough for you, John. Please feel free to let us know about other parts of your previous live work as you go along. Cheers.
Right. Okay, we ready to start?
Let's do it.
Okay. So I'm not an English major, so I'm going to have lots of spelling errors in here. I usually have my wife check this, but I threw some of this together and so there'll be lots of spelling mistakes. Just ignore those, okay? So digital literacy.
So John, just before you start, are you able to share screen from your laptop? Just do a normal old Zoom share screen as well.
Okay, let's just
that would be excellent.
So wait a minute, let's see. So where are we? Share screen. Oh, I say sorry. I know. I'm in. Sorry. I thought we already had that set up.
That's okay. All good.
I think it's in. I think we need to go to this and
yes.
Share screen, and then we want to make sure it's on the
share computer
yeah,
sound as well.
exactly. Do we need that on or not?
Yeah, that's all.
Okay. So what do we do now? Where's the? Okay, I'm just going to share the.
Yeah.
Well, I want to share the screen, so this is the screen, isn't it? But I'm not sure. That's what's bad. If I just do the PowerPoint, then I get out of it. So let's just try this.
That'll be just the folder, actually.
Uh-oh. Yeah, you're
Can you
right.
share just,
Where's the screen?
Can you share just this?
Okay, well, let's just try that first. Might have to do it again.
Yeah, all good.
Can you guys see it?
It'll probably be coming up in just a minute.
I'm
Not yet, but yeah, it's coming, yeah.
No, that's, yeah, I thought we already had this shared, but maybe not. Let's see.
We're living one of the digital challenges. Everything set up before was just the screen share piece that we didn't have. I think another way to do it, Richard, is just if you move that closer, just down in front of Rodney, it'll be close enough for us.
We don't have the authority to share because this website was this company was set up by.
No, he can.
Let me do this again.
He can
Share screen.
It's just not letting him share the full screen, only individual programs.
You can choose share.
So let's see. I want to do the PowerPoint, but it's
click on the advanced something.
Well, if you clicked on this advanced button.
Sorry, everyone. Sorry, Ivan. Just take another couple of minutes. Otherwise, we can just watch the main screen. That's fine.
this again.
Yeah, we can probably like watch the main screen.
Yeah, it says on share screening, so it should be.
Yeah, we can see now.
Hey.
Okay, great.
Yeah, it
Okay,
works
thank you.
great. Yeah.
So how do I? Okay. So are they seeing that, or are they seeing my?
This is that.
Okay.
They're actually seeing
No,
your-
so
We can see your screen now, and we can see your PowerPoint presentation.
they're seeing
Yeah,
your-
that's fine.
Excellent. Okay, John. So
Yes, there you go.
Go accordingly. We're all good to go. Thank you.
Okay, so I have no notes.
Those
Oh,
are your
well,
notes up there.
well, whatever. I should have. Okay, we'll just roll with this.
If you turn your...
That's okay. I don't need
this way.
notes.
Okay.
I don't need any notes. Okay, so yeah, digital literature. I'm going to talk about some of these things: collaboration, creativity, creative thinking, communication. Probably one of the biggest things, though. Not a lot of this makes a lot of sense, unless. Let me see. I've got my right button here. How do we forward? Unless we have seats, we have people in the classroom, and so I'm going to talk about that a lot too. We want to get people in the classroom so we can teach them digital literacy, and that's been a struggle sometimes in engineering. And I actually like this quote. It's been a disconnect between creativity, innovation, and engineering. So a disconnect. Educational programs focus excessively on narrow and deep technical specifications. Little room for developing the ability to think and act creatively. So, engineers are ill-equipped to tackle problems today. And so as an educator, and I'm sure you've seen this over the years, we've sort of been hammered as educators on this, well, the creativity crisis. What are you teachers doing? What are you teaching? There's no room for creativity in schools. You know, our education system's killing creativity. And so this is what we need to do. What are you guys doing? Come on, you teachers, pick up your act, sort of thing. And so there's lots of books on, well, what should we be doing? The art of innovation, and self-help books, and TED Talks, and how to. Lots of buzzwords. And so this is great, but how do you actually walk into a classroom, you know, when the rubber hits the road, and actually stand up in front and teach creativity, innovation, critical thinking? How do you actually teach this? And I start, this is all this class content's available to you, but I show the students this. So what do you see? And I ask them the question, what do you see when you see this right here? And obviously some of the comments that come back are pollution, trash, rust, decay. Yep, that's pretty much what we're looking at here. And it's all over, washed up on nice beaches around the world. And sure, the word opportunity sure is never in the mix. But then some lone individual, who knows where, comes along with a few basic hand tools in desperate situation, cuts the top of these lids out, and creates an industry with a piece of chalk and a few basic tools. I mean, this is a great example of creative genius. I'd say the first person who did this. And I actually paid over $120 for the top of an oil drum. I didn't know what that was initially. I was on the Seattle waterfront on this specialty stores, and I saw this and I thought, that is beautiful. What is that? I've never seen this before. I like things that are different. It's not just the franchise idea. And so I saw this, and then the lady told me, well, it's on top of an oil drum and they come from Haiti or somewhere. And anyway, I paid $120 for one of these. Why? Because it's unique. It's different. People like unique. They like different. And this is a one of. I've never seen one like this. It's like this little tree of life. You see these drop tanks in the war. Go through these stockpiles. If you ever go past these army base type surplus yards, there was just hundreds of these tanks. Just nobody knew what to do with them. They're just trash. You buy it for $40. And again, no one wanted them. And then someone comes along and sees that. Wow, what a beautiful piece of streamlining. Wow. And starts an industry. And this is Utah on the salt flats. You think of the cousins, uncles, you go out to your grandpa's, you can get an engine, a wheel and an axle, and you've got the body of the car for $40 and you're on your way. And what a beautiful interpretation of something that was a piece of junk. And this is actually a Siemens race. Same thing, I was in the UK, in England, and there was like 120 cars in this race. And I went to the race, and the idea, the kids get the kit car, and then they have to design a body, aerodynamics, and it's these electric vehicles, and a really fun race. And after the race, before the race, I went over and I looked at some of the cars, and it was just spectacular. This is one of my favorites. But I talked to the kids, and oh my goodness, high-end machining, autoclave, carbon fiber, thousands of dollars on the paint, and So man, most schools I know can't afford to do this and they don't have the stuff, but nice car. But actually my favorite was this little light one. And I asked the kids, I said, how did you do this, man? This is amazing. And they really didn't want to talk to me. They're like, oh, you know, no, look, this is beautiful. And I see where they cut a hole where the wheel was scraping. And anyway, eventually one of the kids talked to me. He said, well, I did it. And I said, how did you do that? And he said, well, I just basically borrowed my dad's cargo rack and cut a hole in it, dropped it over the body, and off I went. So, wow, that is a really creative interpretation. And in one hand, you say, well, is that cheating? No. If I'm starting a company, these are the sorts of people that I want to hire. Someone that can think creatively and save me money and just get the job done. Super light, super great idea. Now, great examples. But again, how do you teach this? How do you walk into a classroom? And just from the engineering, I'm going to cover lots of areas in engineering, but from a mechanical engineering perspective, what are the core things that happen in the class? Well, the first one is you draw parts. This is how you draw a part, holes, dimensions, and then you put all these parts together in an assembly, and then you do motion and analysis. That's sort of what happens in a semester class in mechanical engineering. So I backed up and thought about this for a while. So what's actually happening? Copying. That's what we do a lot of. I draw a cylinder, the students draw a cylinder. I modify the cylinder, the students modify the cylinder. And then I thought about this for a while. I said, okay, they're just copying. So if I got that cylinder and a sphere and I said, create a new shape from those two shapes. That seems very, very straightforward to me. And I said, well, what do you mean? Well, I just want a new shape. And well, like this, you just round the edge. Oh, okay. You want us to create a new shape from the two. Yeah. So now I would say, instead of the cylinder, I want you to do a cube. Again, starting real basic concepts here. And the kids are like, oh, well, what's in the professor's head? They can't think. Students have forgotten how to think. They can't create. They're good at parroting things, but they're not good at creating. So I said, okay, do this. And they're like, oh, what's in his head? He wants us around the edge. No, not what in my head. It's too similar. I want you to make this your own. This is how the world works. I want you to take those two shapes and create something new. Then you got to stop and get out of the way for a minute. Sometimes I'm usually in such a hurry and I'm like, go, go, go. It's like, no, think of something. And kids get frustrated. A new shape from those two? Yeah, come up with something else. So you give them a few minutes because this is frustrating when you actually have to think. I don't think, we just do and we plug in some formula and something works. No, here's another idea. Just take the sphere out of the center of the cube. Oh, wow. Anyone, have I used all the best ideas? Is there anything left? What about taking the cubes out of the corners? Oh, well, you have used all the best ideas. No, I haven't. There's 100. Stop and go back and come up with something else. And so these are very simple principles, this simple combination. And so the kids start experimenting. They say, okay, well, how big should the sphere be? I don't know. Make two on opposite corners. Round a couple of edges. There you go. You made that your own. That's what I'm talking about. This is what happens in the real world. And then you get out of the way and the kids start to combine and create. And so in engineering, I'll stand up the back of the class. I see 40 different examples. Okay. These are all just, again, from two simple shapes. And then we have rendering software where you can just add a little color and make it look beautiful. I mean, wow, make it your own. Now, why is this important? I'm going to focus on this idea of random combinations driving innovation. And this is right across the spectrum. I don't care what major you're going into, think about this random combinations. And there's lots of places I can go with this right here. What happens if I use a different shape than a cube, a pyramid? Okay, So I'm not going to go down that road, but there you go. Now, why is this important, this idea of random combinations driving innovation? So the creative people, I'm going into music, I'm going into art, because I'll be able to create and do amazing things. And I think of music, and I think who started this. Look, I was into AC/DC when I was 19, and then Queen came out with this, I'm just a poor boy, da, 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 da. That's opera. I hate opera. And then it was in this rock song. This random combination, and think how that's exploded in music today. Random combinations, pop, rock, everything. But that's the first example I can think of was Queen. We see it in art, these random combinations. Now, you don't have to say a thing. You look at this picture of the gun with cigarettes. I don't care what language you speak. Oh, I get the message. Cigarettes are going to kill me. Blaze your own path. So art and music is creative. But STEM? How? No. You give the kids an example like this. This is on a quiz. There's one answer only. Everyone gets the same answer in engineering. That's what people think. That's boring. That just puts you to sleep. So back to this idea, I'm expanding on this idea of a sphere and a cube. And I gave the student, this is right out of class. So I'm saying, I want you to create a new case. We're going to do something creative, and I was based on a soccer ball and that case. Do something new. Man, this annoys kids because they've forgotten how to think. They don't know where to start. Okay, and obviously there's some lead up things to this. And I say, well, what do you see? What shapes do you see? Well, I see a circle. I see a hexagon. Okay, let's start right there. Draw a circle, draw a hexagon. Well, in what order? How? I don't care. Start with a hexagon. Start with a circle. Go. And then get out of the way. As an educator, get out of the way. Walk up the back of the classroom, let them struggle, because creativity means to struggle sometimes. Now, you can prompt them along, but once they get to there, then you're walking around, well, you got some circle. What about spheres? Put a sphere on there instead. Okay, and how about you? What if you do this? And so it's easy for me to offer suggestions. Okay, and we follow this train of thought. There's our spheres, put them on the corners. A round edge takes 30 seconds. You put a nice big round in there, cut it in half. Let's print it. Okay, so we print that. On the bottom, simple, that's just an extrusion. And I let them make mistakes. I don't tell them up front. So they printed this and it used a lot of material. They got it back and said, this is pretty heavy. Did you need that much material? No, we don't. And then the lid just slides around. And so they're asking me, how does the lid stay on top? Oh, you need to understand the lip command. Well, how does the lip command work? Let's do it again. So we do it again, prototype. But here's the difference. Why are we learning this for? Why do we need to know what the lip command does? No, they want to know. So instead of me telling them, we print it again, beautiful, right out of the machine, bring it into class the next day, left it on the table, someone dropped some apples in there. I never thought of that. Well, it could be a container. So see where we're going with this. Take something boring. Every product can be improved. I mean, for an educator, you've got to think of some creative things. I take this, a bland light cover with the letter S. Get out of the way. Now, kids are going to be frustrated, but they will come up with brilliant things. Now, look at this. There's the S shape. There's the S shape. This is such a simple design. And all this student did was loop this half circle from one side to the other to create this beautiful pattern. And then this pattern, that's looking at it from the top view, they get going on this. They look at this and they go, man, I could put a light in this. And that's what this kid did. He went and got this light for $50 and it was bouncing off the ceiling. It was just magical what happened with this project. Now, if my boss in the engineering department walks by and he sees me doing all these crazy colors and stuff, now the focus in engineering is mechanical things just like this. This is what we do in mechanical engineering. We draw a helix. I have to do this. That's part of the class. But then I'll take this and say, okay, we learned to do a helix. I want you to combine that with a set of stairs. What? Off you go. You know what? After 3 or 4, 7 or 8 times, the kids just run away with it because they know they can think, they know they can create. Now, here's what one student came up with. Now, it's a beautiful interpretation. You see this helix staircase. Now, here's another one. A helix and a staircase. Now, this spent a year on the Stratasys website. And you can see I've been doing this a long time. This is 2010. So I've been working on this for a lot of years. This student won $1,000 cash and prizes. And his parents told me later, it's the first class my kid ever took where he actually made money. So anyway, now here's the key though. Same input right in the center. What have we got? A spring and stairs. 2 extremely very different outcomes. That's the goal, to stand up the back and see 40 different things. The kids can't copy. Hey, what's the answer to the homework? 27.4. No, I need you to make this unique. Again, here's a sweep command. This is what we're covering today in class, the sweep command. We learn the sweep command. Here's a beautiful little sweep. It's like a little auger idea for a mixer or something. Look, I don't know about in Australia, but we need more diversity in engineering. We need other students. This is what attracts students from different backgrounds, okay? I don't want 35 guys and 5 girls in my class anymore, okay? So you do stuff like this. Wow, this is a beautiful interpretation based on that sweep command. I actually couldn't figure out how the student did this. Because I steal their ideas. And so I asked the student, can you show me how you did this? He had to show me 3 times. I'm, what? I'm not sure. Okay. So anyway, that broke. 3D printed snaps. The student wants to do it. I don't have to ask him. I want to print that again. I want to do it again. Now, here's the beautiful thing. You'll get students coming up. Oh, they thought of the best thing. I wish I could think of things. I wish I could be creative. Well, take what they've got, learn how they did that. That's the first step. Draw that. When you can draw that, then make it your own. How could you make it your own? What other shape does that curve look like? Well, it sort of looks like a heart shape. Maybe mirror it, borrow. I just don't want to recognize that I'm not going to use the word copy because that's what happens in the real world. Cars, they sort of look the same. You borrow ideas, okay? And so here's this idea and my wife said, that's a stupid idea. Who would ever buy a spider web box of chocolates? Anyway, there you go. So, and here's where I spend a huge amount of my energy. I love the simplicity and the beauty of engineering. If we can get students to understand that engineering is beautiful and it's simple. And I've had students stop me right here and they said, look, this is way too complicated. My kids cannot draw things like that. Okay, well, if they can draw a line and a circle, we're pretty much done. So if you can't draw this is not a this is going to take 3 days to draw. This is going to be really hard. We're going to have to do, nope, 30 seconds. So like I said, if you can draw a line and a circle, off we go. Go to the helix command, identify the line, identify the circle. There's 1/2 a helix. Now, what if we rotate around the center? Well, it looks a little bit rough in where they join. Let's put a sphere on top of that, copy and rotate. So this takes 2 or 3 minutes. So all my examples, they look complex, they're simple. The simplicity and beauty of engineering. Now, here's where you've got to get out of the way as an educator, and you need to work harder as an educator. If I go back up here, what if that line down the left-hand bottom there, if that line was a spiral or it was tipped over an angle? What if the circle was a hexagon or a triangle? What if we move things around a little bit? What if instead of 3, we did a copy and rotate of 4? Yeah, some kid always does 100 and the machine locks up. But anyway, here's the beautiful thing. 3, 6, 9, that sequence joins back together. That is a beautiful mathematical concept. Go talk to your math teacher of how that happens. And so you get out of the way, stand up the back, you'll see 40 different things, amazing patterns. And then let's 3D print it. because the best ideas aren't in my head. And I'm going to focus on that idea a little bit too. So I printed this, there it was. And guess what one of the girls did? Come up and said, well, I'd like to shrink that down. I'm going to scale that down really small and make a necklace. Wow, I would have never thought about that. So here's the beautiful thing, and I'm sure you can do this in Australia. This is how you start your own virtual store. Now, you don't have a 3D metal printer. No, you send this up to companies like Shapeways. They're in the States anyway. And this costs $35, 92.5 sterling silver. The girl goes down, buys a bracelet for $20. People see her walking around. She said this, people saw me walking around this, they wanted to buy one. So that's really cool. Where'd you get that from? I made it. Well, how much was it? Oh, $120. You want me to get you one? Yeah, okay. Start your own store, do your own stuff. Now, how many variations can this girl come up with? Hundreds, because she has the template, she has the idea. And I just had to show this. I have this 3D print, I didn't bring it, but that shape on the left to the right is nearly exactly the same. All it is moved off center and patterned differently. It's almost exactly the same. And that's the beautiful thing as you get into this, just making very small changes to make something your own. So again, a chair, this is right out of class. I'm not bringing stuff up that I don't have in my class content. What about this chair? What is it? Again, you think, how long does it take to make this? Well, if you can't make this in 3 minutes, it's not in the class. So this table is 3 squares. It's the software, it's powerful. You click on 3 corners, there's your basic shape. Let's grab those loops there, round the edges. How big? I don't know, round it, whatever you think. Then we hollow that out, just say hollow, hollow, thin wall, bam, there's your table. Simple, beautiful examples. I've got 150 of these. I'm only going to go through 2 or 3 more and move on. I love this concept. This is again, software, intersections, 2 ellipses, one's offset, just a fraction. Give me the intersection between those. One pushes down, one pushes out. There's the intersection. Oh my goodness, the amazing things you can do with this. Once you have this, you can easily put a loop around that. Where could I go with that? Get out of the way and let the kids go. These are the sorts of things they do. And you look at this, well, gee, I could just put a ball on that. Yeah, it actually got stuck right here. I got to back and redo it. So all these ideas of these combinations, and again, I didn't do this. I could never think of that. That idea was never in my head, the mouse shoes, okay? So we do a lot of artistic, crazy stuff. But then I'm like, hey, come back to me, come back to me. We want to make something, we want to make money, we want to do a product. Take the boring tire and add that stuff in. This was a class project. And I can tell you what student, I can still remember this student up in the top right-hand corner, he was from Japan. And you can see his culture coming out in his designs. And you'll see that, the culture, people's culture, if you get out of the way and let them experiment, off you go. So anyway, all these ideas of changing products. Here's another one. We have to use the Loft command. The kids learn how to do the Loft command. The Loft command, it's very simple. It's two circles on the top, different plane, 2 circles. Just takes 30 seconds, put a loft through there. Put that in your gig bag. Here you can rotate down the bottom. Now, we look at real products. And we've done 40 different things in class, and I'll say, okay, go back to your little kitty of ideas and make this table cool. So your mum goes into the store, instead of buying this last year's model, make this year's model. What are you going to do? Here's an example. Now, I don't know what about you guys, but when I look at this table and I look at that, I know which one I'd want to buy. 3D print, yeah. It's just a beautiful interpretation from that to that. Again, so when people say, well, this is art, this is stupid, what are you doing all that for? Because you can add it in your products later on. And you know what's been huge? You want to get press. You want to get the news to come over, and that's what happens at university. You got any good stories? No, we just got the textbook doing the same old thing. No, I've got so much press from these ideas because the press like different ideas. They like unique too. And so I would say to the educators, when you're in a museum, when you're anywhere, this digital literacy, formulate judgments, incorporate limited information. This was on the state news, like this was on the 6 o'clock news. This is what started the industrial age, the industrial revolution. And I'll just play the little video. This was a Newcomb steam engine. I was in the Henry Ford Museum. That's where it was. Beautiful, one of the best museums in America. If you ever go somewhere, it's in Detroit. I'll just play this real quick for you. Hopefully you can hear the sound. Tell me if you can't hear the sound.
Well, a couple of photographs showing just a couple of angles was all a freshman at Utah State University used to recreate a working model of an 18th century steam engine. And now he's being recognized with an award given by the largest engineering company in Europe.
One of the powerhouse pieces of equipment that drove the industrial age.
Steam engines were once one of the primary sources of power until the early 1900s. Now, students at Utah State University took a challenge to create a 3D replica. The whole project started when Utah State engineering professor John DeVitri went to the Henry Ford Museum in Detroit, Michigan, where he found an old steam engine that was once owned by Ford himself.
I said, that'd be a great 3D model if we could create that in class and make a 3D print of it and actually get it to work.
The museum didn't have many drawings or much information on the piece, but DeVitri decided to present the challenge anyway, asking his students to make the steam engine model for the semester's final project using just a couple of pictures from the internet as reference.
Initially, the kids are a little bit, oh, it's missing, half of it's missing. Where's the top view? Where's the side? And I said, you know what, that's real life. You need to fill in the gaps and just do the best you can.
USU freshman Charles Ruse.
So the point there is, this is amazing. Freshman students doing amazing things. Let them fill in the gaps. You don't have to give them all the information. And just brilliant ideas. Again, you got to have art. This was a great article. This guy was out of San Francisco, wrote that. Hinges. This was actually on a midterm. And this is actually quite tricky to do the motion for this to make it go up and down. So anyway, biomimetics, another interesting topic. Some kids are like, oh, what is that? Oh, maybe I want to do biology. Okay, I'm going to combine a hinge with a fish. How does a fish move? Obviously, it doesn't have a hinge. So here's what was crazy about this. So I went over to the art department and worked. And here, if I asked everyone on this call or ask the educators, when was the last time you went over to a different department, because we're all stuck in these silos still, went to a different department and said, hey, let's work together on the project? It's a little bit of work. We went over to the art department, and you know what? Maybe the worst thing that could happen, I had about 35 guys and 5 girls in my engineering class, and in the art department, it was basically reversed. So I thought, maybe these guys will actually get to meet some nice girls and vice versa. Anyway, so the art students, I said, you come up with the design, do the idea, and then we're going to design it in 3D CAD. So here's one example. This is beautiful. Here's the art student drawing it, and here's the fish 3D printed. That's actually the 3D CAD model. That's a very nice interpretation. Again, the art students, and this was a really big deal. All different designs. Nothing's the same. Everyone, they got to do something different. This was really cool. It spun around the center, and here's another one. This was actually the one that made the press interview. So here's the drawing from the art student, the weird fish. Now, when my engineering student saw that, he says, he's on the team with this girl, I can't draw that. That's ridiculous. I'm just new to this, you know. Do the best you can. That was the best he could do, which is a pretty good effort. It doesn't look quite as cool, but that's what you got to do. When you're on a deadline, produce, make something, no excuses. And here's what it came up with. I didn't know anything about Mindstorm or Legos. I didn't know they could do this. So anyway, I incorporated that into class, but there's the fish swimming. It's like this universal joint inside there. You know, and talk about digital literacy. This is a lesson to me too. I just assumed. So that the guy and the girl that did this was interviewed, and the girl, the art student. So the TV cameras are there. We're at Space Dynamics Lab. We're in the big lobby. It's just beautiful. And the cameraman's there, and the reporter, and they put this microphone in the girl's face, and bam, she's off. She's like, yeah, I did this, bam, bam, bam. I created this, and here's my sketches. Just beautiful. Then the engineer has his chance to step up there, put the microphone. He could hardly speak. It was just, wow. We don't do a good job of that. We just assume that engineering students can get in front of a camera and talk. Well, they can't. And maybe I was a little out of line here after like 2 or 3 minutes of just stumbling, and it was just, oh my goodness. I took the time out, Andrew. I went round and we went for a little walk. Andrew, you're embarrassing the mechanical engineering department. You got to step up, man. Now look, you told me this story one-on-one. I want you to walk out. I'm going to stand next to this, and you better go. Anyway, he did, and it was good. But don't assume. Kids got to learn the public speaking a little better. Again, yeah, we do engines, we do stuff like that, but branch out, do some other stuff. These are simple. Parts in an assembly are simple. These parts are simple to draw. Once you get one, wow, that's what a camshaft can do. Now, I've got to highlight, the best ideas are not in my head. And when I first went into class, I was a little bit like that. I don't know if you've seen that Matilda film where the teacher comes in and, you know, swings the little girl around by the hair. Anyway, the teacher walks in, I'm smart and you're dumb. Shut up and listen, basically. And so sometimes as educators, we think, well, we know all the stuff. And it took me a few years to figure out, no, the best ideas are in my students' heads. I got to get them out. This is how you get them out. Same thing. Students come, oh, I wish I could have thought of that. If only. Well, you can. I want you to take that. We're going to do another project. Make it your own. How can you borrow ideas and make this your own? Beautiful. You like rowing? There you go. Then I stole this off the student. This is what I do. I steal ideas too. If kids come up with good ideas, this is a tutorial now. Robot tutorial. I mean, you look out on, I've got a lot of classes on Udemy. Here's 8,000 plus students have taken this worldwide. So this came from a student's idea, rowboat, whatever. And now I've got a class on it, assemblies, okay? So I'm gonna race through this, but the idea is, look, start with something. Once they draw it, then we're off. Well, I don't know, table, draw a Z, extrude it, great. Now as the teacher, yeah, it's a little thick. What if we want to fold it up? Can you put a hinge on it? Can you refine it? Oh yeah, let me try that. So off they go. Well, you can't get a chair under that one right there. Oh, well, yeah, I could leave this front open. Could we fold it up? So this idea of combining letters, this actually worked really well for me. Combine a letter with a chair with a desk. Now you got to look at a number. It really makes you think. The letter 2. Oh, man, I don't know how we'd sit on that. Where would maybe 4. So I want you to think about that. Wow, the letter 5. Again, the idea sure wasn't in my head. I couldn't think of that. But what a beautiful interpretation. There's your seat. There's your 5. You got your little desk stuff. Then the students, well, how could I make this? Maybe I could sell this. Yeah, well, how much could you sell it for? I don't know. You're going to figure that out. Well, how would you make it? They're interested. They want to learn. They want to go. I was in China. Got a whole different alphabet there. They can do all sorts of crazy ideas with that. So again, alphabets, I'm going to wrap up here with this STEM to STEAM. I'm not sure, why do they call it STEAM? Why couldn't it be STEM to teams? Anyway, yeah, mechanisms. See, and can you see how I'm sneaking into this idea of mechanism? That's a huge part of mechanical engineering. So we sneak into that idea with these little ideas, an O and an X. Let's do that. Then we start making real products. This is an idea where just a light you could just wind down and wind up, okay? Lots of research on this, research papers, huge amount of effort went into this, just proving concept out, you know. I don't need to brag about that. Let's get out of there. Anyway, it was this idea of conceptual design blending, okay? So anyway, again, if the boss walked by and saw some of this, he'd be like, what the heck are you teaching in there? Well, need to back up, take the long way home, It's okay to do stuff that's not tangent parallel all the time, but we're going to use this. You're going to put this in your bag of goodies and you're going to learn how to create and 3D model. If you can draw these parts, you can draw a lot of stuff. Now, here's the kicker. Everything I'm going over here is, it's online. It's all free. The software's free. The information's free. Now, I'm not working for free. Siemens paid me a lot of money to do this. So thanks, Richard, who's in the background there. So I'm not a nice guy that I'm making out I did this for free. And all these classes have just, I mean, hundreds of examples of mechanisms and cool ideas. Yeah, some crazy ones. Some things that work don't actually work in real life. I tried to make this, actually bought the metal. It was crazy. Anyway, let me just skip through this. So I've got all this huge amount of PowerPoints on all sorts of things, mechanisms, frames, sheet metal, the quizzes ready to go. Because this is one of the biggest problems educators have. Oh man, next week I've got another quiz. So I put together 100 quizzes so you can just go through, oh, I think I'll do this one this week. I think I'll do this one this week. So you got all the quizzes, you got the lab, the homework. Let me just jump out of this and maybe I'll jump to, and hopefully my screen is what's showing here. And Cheryl, you're gonna have to tell me, let me see.
We can see the PowerPoint slide set at the moment on macro view, John.
Right,
So, and before the whole way, we were seeing the actual presentation. So
good. So here's my point.
Money would reshare the screen to show that particular.
It says I'm still, you're sharing your screen. Yeah, I think we're good.
yep, you're still sharing screen. We can see your final slide with the engineering graphics.
Okay, so here's my promise to you. I can take any teacher in any background and I could have them walk into a classroom and not embarrass themselves if you give me 20 minutes. That's my promise. So in this, and how does that work? Because look, I know where the teacher's pain is. I've been to 100 different schools. I've talked to the teachers, you know, overworked, underpaid, it's the same old story. It's pretty chaotic out there. Maybe it's not here, but that's what happens where I come from. It's chaotic. So I'm just going with you guys are organized, okay? But here's the deal. So this is the class. The teacher just opens up PowerPoint and just basically reads this and says, okay, this is what we're going to do. And so I'm just going to skip. Okay, students, this is what you should see. So again, the teacher doesn't know what's going on. She's just reading this or he's reading this. This is the interface. And let's get started and create these basic shapes by going to the box command. And so every time you see this little movie up here, you just click this, all the work's done. So, okay, we're going to the box command. Is everyone there? And if you need to stop, you just stop. Hey, is everyone there at the box command? Did we do that? You need to back up, then back up. Okay, so push your mouse in or out. Okay, now let's go back to that box command and see right below on the arrow. Does everyone see that arrow? So all the teacher's doing is just talking away through it. Pick on the cylinder. Okay, click anywhere on the screen. Okay, push that out, in or out. There's your cylinder. So all the teacher's doing, and I mean, this is pretty simple, but this gets complicated. You get into mechanisms and all that. That's what we have to make easy for the teachers. And the teacher's basically just reading, okay, what we just did, the box command's part of the ribbon bar. And what is the ribbon bar? This is what it is. Did you see how these things came up on the side? Everyone look at that, great. Okay, now we're doing the quick control. Here's the video again. We see the video. Now everyone go down to the bottom corner and just click on that box. You seeing the different views? 100 PowerPoints from the most simple to the most complex. This is what you're getting, okay? So that's what's happening with that, okay? It's all ready to go. Again, you got your homework, your lab work, all the heavy lifting's done. Now, Richard, do you want to take some questions now, or you want to go? I've got a whole bunch of other stuff to go through, but
yeah, we can definitely take some questions. I can't see who's online, but maybe we can see if there's any questions online.
I've been monitoring the chat line, and Ivan has too, so
yeah, we can look at the chat. Do you have any questions? You can write them in the chat. We have a few comments from Cheryl. Yeah, hooray. The boss here from Rosalind. Minecraft to reality beyond. Yeah, that's also pretty good concept, Minecraft. Anybody would like to ask questions?
Did you have a
I do, yeah.
I think it was a great
That's
talk.
really interesting. Oh, is he still talking?
Yeah. So we got a question here.
I think that's interesting, and I think that this is probably, I guess the thing is that I'm from industrial design. We're kind of bridging between art and we're bridging between engineering. It's the saying, isn't it? Designers get the right design, and engineers get the design right.
Yeah.
And I think that we do a lot of this, and I think that in a slightly different kind of way. And I know that you're talking about teaching this within the context of the School of Engineering. I think that I totally agree with what you're saying. I think that the repetitive tutorials have never done us any favours. I think that we've worked it in a slightly different way, but the students all do different things, and it's through that struggle that they learn, really. So I think that it's in ENG here in the industrial industrial design is part of engineering, and we've taught this stuff for a long time in industrial design. So we've taught Rhino, SolidWorks, and a couple of materialized software. So they've gone through quite a few things that we teach them. So I think in terms of industrial design, digital literacy is no problem. But I think that translating this into engineering has been something that we've looked at for over the years quite a bit. And I think that that's kind of the conclusion of new courses coming in engineering that are going to sort of teach much more of this kind of approach. I think that the only thing I would be a bit unsure about would be, I've found in the past that I've probably been doing it a similar amount of times a year, is that students ask lots of questions, and the people that they need people near them that need to know how to answer those questions. And I think that it's a bit like learning how to drive. You can't do it on your own. You need people like you to ask questions.
Good point.
At that, I just was I think that having tutorials that perhaps other people can use that aren't as skilled as you, it might not be such a good thing. But I suppose in lots of schools, they just don't have that, can't have the expertise.
Yeah, good point. Yeah, well, when you say expertise, man, I've screwed up a lot of stuff.
Me too.
You know, so who's on the? This is bouncing back right now. Can we put it back on mute or?
Yeah, I think it might just be Shujin's machine. So Richard can turn the volume all the way down on that. We should be right.
Okay. You know, one thing I will say, internationally, where sometimes, do you ever go to presentations? Maybe I'll just jump back to this and this bit along what you're saying. So this is bouncing still. Okay. So let's see. Where is that?
We're all good here.
Cheryl, do we have a hard stop at 12?
Ivan, I think we do in terms of the webinar. We can go a bit over.
We can stop at 1, and then we can do another link. I think you have arranged another link, right, Cheryl?
Perfect. So we'll stop the webinar after this question.
Yep.
And then we can move into the team site link and continue the conversation.
Cool.
Okay, so what do you want to do?
Yeah, I mean, you can, if you want to just go through whatever you were going to share, we can wrap it up.
Yeah, I think one of the things that I would say is, sometimes you sort of, when you know something, you assume other people will pick it up or know it really quickly too. And internationally, this has been a problem too. I'm working, and I have been working with a lot of schools all over the world. And did you ever go into we've all been to these seminars where you come out, I don't know what that guy was talking about. What was that? And you just smile and you go, thank you, that was wonderful. Well, guess what? That's what these teachers, I was actually in Turkey probably 3 or 4 months ago. I was in Ankara. And they were great, actually. They speak English, and it went really well. And but what's interesting is when you try to go internationally, and they got all sorts of issues and other things that they're dealing with. One of the things here was, man, their money was dropping through the floor. I mean, their money had devaluated like 50. And so you had, I mean, the girl that was showing me around, she was trying to get out and go to Germany. And so it's interesting to what you want to get. Yeah, a lot of smarter people that if they can get out, they'll go to Germany where they're making some money. And this one here, I was working with these guys probably 6 or 7 weeks ago, maybe just a little longer before that. And I wasn't even sure where this was. It was in Slovakia. And then I haven't heard from these guys. And I'm like, why haven't I heard from these guys lately? Oh, you share a border with Ukraine and Poland. So it's interesting, what's going on in the world. What they're dealing with. Our schools are opened. And, they're dealing with refugees. It's like, man, same in Israel. It's like culturally, there's all sorts of things, and they have the way they set their schools up and the different way they look at things, but presenting some of the stuff that I presented, it went over really well in these places, and especially in South Africa, and we're still working with them. You really got to go back. It's going back to these basic shapes. It works really well. And well, this was actually a disaster. China, man, they really roll out the red carpet. I don't ever plan on going back here, but this did not work. I was in this room and it was a sauna. I was so hot. I had a black shirt on like I got on. I went into the bathroom a number of times and soaked my shirt. It didn't look like it was wet. I came out, and my computer was shutting down and rebooting because it was so hot. And no one could speak English. And so it was just a really bad situation. It's just, everything's lost in translation. It's like you tell a good story, da, 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 and then the translator's like, hung chong bong. And everyone just sits there with a blank face and you're like, that didn't work. And so, there's certain things that just don't work internationally. I'm sorry, I'm getting off on a tangent there.
No, I get what you're saying. And I get what you're saying about starting with I think the thing we've learned over the years is that, I've learned over the years is that moving too quick at first is where you lose people. Once you've lost them, you can't get them back. And the best thing to do is go at the pace of the slowest person for a little while and then move along ahead. And I think that's basically what you're saying, isn't it? That's the way it's done. Yeah, don't leave people behind and do visual. You'll see a lot of stuff I'm doing here is visual because I've got a lot of students. Some of the classes I went to in some of the states, they don't speak English. I'm in the United States of America and I go to a school and there is not even some of the teachers, there's none of the students speak English. You go into the class and it's Spanish and you need translators. And so you need visuals. You need to be able to relate to people with visuals. And so I would say a lot about, visuals. Here's another disaster. I don't know how I got off on disasters, things going wrong. So I bought a HoloLens and I wrote a class on augmented reality. So I'm writing this class about how you get stuff from 3D CAD into the HoloLens. And man, this thing gave me motion sickness. And it knocked me. I don't know if you ever get motion sickness from something, but if you ever got motion sickness on a boat, I'm out for like 3 or 4 hours. I got to go in a dark room and cover my eyes. I'm like, oh, I feel so sick. And I thought, this is a disaster. We can't do this at school. Could you imagine presenting that to 40 kids? Oh, only 7 of them threw up, So anyway, there's another thing that didn't work, the HoloLens, This guy is one of my best friends. We did some fun things with him. Anyway, you know what? We're at 1 o'clock, right?
Cheryl, should we all jump into the Teams meeting?
I think we'll just conclude the session and maybe continue with the Teams meeting. Cheryl, will it be okay? I don't know
yes, that's fine.
We can actually continue the Zoom.
No problem.
We can, but I'm just not sure.
That's fine, Ivan. So I was just looking at the attendees on this call. we're mostly internal Griffith, and Sri also has the link. He's been listening in. Siemens and Bentley do collaboration together, and he's just been relating to me via text. It's pretty exciting to see what you presented, John. So thank you so much. I know finishing on disasters doesn't mean that, I think we're just about to launch into that conversation in this next hour about reality and constraints and what we do inside those constraints. So I think that's a really good segue. So perhaps we give everyone hey, Sri, there you are. Shree's been showing me how he got the screen technology to work in his office. So we both almost felt like we were nearly there with the table view, which was great. So if we continue in the Teams environment, that would be excellent. Take a stretch break. Make sure you fully close out of Zoom. Just quit all the way out of the function. We know that Zoom fights with Teams occasionally. So if you do that, and then we can just dial into Teams and have a conversation around the table. So we'll say in 5 minutes time, if that's good with everyone. There are also sandwiches in the room. So if you're on Gold Coast campus, please make your way up to the G39 level 4, and you can help yourself to some lunch. Okay, see everyone soon. Thanks, Ivan.
Yeah, thanks, Cheryl. Thanks, everybody. Thanks, John, for interesting presentation. Yes,
See you, Sri. Bye.
Yeah, bye.